I am Raima Devi, lecturer in ACE. I am going to deal with the microwave communication and television subject, and today's topic is basic principle of radar. So in this session we will see about what is a radar, what is the main principle of radar, and what are the main components used with our radar system, and mainly what are the uses of radar. And we are seeing about the advantages of radar, and we are using about the applications also when we are using a radar. Okay, so basically what is a radar? So the abbreviation of radar stands for radio detection and ranging system. So the radar is nothing but a detection system which is used for detecting the target which is placed at a longer distance, and while we are using the radar we will transmit some signals towards a distance or towards a target or towards a device, and we will get some signals from that particular target or any place. Okay, so when we are having the signal receiving from a target, that signals are going to be calling as echo signals. Okay, so while we are transmitting some signals, we are using a radio ranges of signals, that is we are going to be calling as radio waves. Okay, so we will transmit some signals like radio waves from the transmitter, and we will receive some signals from the target or any distance of a object. Okay, while we are receiving that signals, we will having a detection of range and what is the shape of target and what is that object. Okay, and specialty of radar is to detect that particular object also. That means when we are placing a camera in that particular radar, we can have a clear picture of that particular target. So that is the main intention of radar. So the radar is nothing but an radio detection and ranging system. Okay, it is mainly calling as object detection system. That means which will use some radio waves to determine the range, latitude, altitude, direction or speed of the object. Okay, that is the main definition of radar and main intention of the radar. So when we are having a history of that particular radar, so the first time when we are having this signals to be passed from the transmitter, so in that we have to introduce that electromagnetic waves. So that is going to be introduced in 1886 with the help of H.R. Hertz. Okay, so when we are having this introducing of the electromagnetic waves, when it is used with our communication, that can be having in 1897 by G. Marconi. Okay, he has done the radio communication. That means he has first it is transmitting the electromagnetic waves for longer distance, and after that when we are having the location of that until when we are having the detection of targets, so it can be done in 1930 by L.A. Hyland. It is the first time he has introduced a aircraft which is located at longer distance. Okay, there is the first radar system which is introduced only for seeing of particular aircraft which is placed at longer distance. So this is the history of radar. And what is the main basic principle, and what is the main principle involved with the use of radar system? So I have already told that when we are having the radar, which is nothing but a detection system. So when we are using this radar, just what is the principle means? The simply we can say that it is having a transmitter which will transmitting some electromagnetic waves that are going to be calling as radio waves from the transmitter, and that waves are going to be transmitted at different directions. So when it is passing at different directions, when it strike off that particular target or which is striking off that particular target, that from that target we are going to be getting some signals reflected back towards the transmitter. So when we are receiving that signals, that signals are going to be calling as echo signals. Okay, so all of the signals are not going to be reflected which are going to be transmitted. Only some of the signals are going to be reflected back towards our transmitter. So when it is going to be transmitting, when it is going to be reflected back from the target or from any distance or from any location, that signals are going to be calling as echo signals, and that echo signals are going to be received by our receiver. Okay, when we are having in the receiver part, we are having so much of devices to detect that particular targets or particular images or particular objects or particular place. Okay, so by that we can know that is the one of the object. We can detect that particular object. So that is the main principle of that radar. Okay, in this figure you can see the aeroplane passing towards the clouds. Our aeroplane is going to be passing above the earth. Okay, so above the earth's curvature. So when it is having a radar which will seize that particular aircraft. So that means when we are calling as aeroplane or any missiles, to detect that particular target, we will transmit some signals from this transmitter. Okay, so when it is going to be transmitted towards the target, it is having some distance. So when it is having some distance d1 and when it is receiving from signals from d2, the time taken to transmit that particular signals and taken reflected back signals, that is having the total time duration. So with the help of total time duration, we can have a detection of distance also. Okay, so radar is going to be calculating the distance, at the same time range, and what is that target and what is the shape of target. All of things can be done with this radar. Okay, that is the main principle of radar. Next, so when we are having the main principle of radar, so I have already told that it is having number of devices. So in our radar system, it is having a transmitter which will transmit a radio wave signals, and that signals are going to be calling as radar signal. Okay, so that signals cannot be transmitted in a single way. It will transmit at all of the directions, but when it is striking that particular target, that target is going to be having some signals reflected back. So by that condition, we can have an direction, which direction the target is going to be placed. So that is the main system we can having in the radar. So when we are having a transmitter, I have already told that in our communication also, what is the main intention of transmitter means which will transmit some signals. So like that only in our radar system, the main part of the radar system is transmitter. That means which will emit some radio waves in a particular directions. And after that, when the signals are going to be striking or touching with the target, we are having some reflected back signals. So that signals are going to be calling as echo signals or reflected signals. And mainly when we are having the reflections of signals, it is also done with in our many directions, not within a particular direction also. Okay, so whenever the receiver is having some frequency of signals, that frequency of signals can be having some signals reflected back towards our receiver. So only that particular signals can be received by the receivers. Okay, so that is the main intention of reflected signals. And in this we are going to be having a Doppler effect. So mainly to understand the Doppler effect, so what is the Doppler effect means, if it is having a transmitter, the source is having a particular frequency of signals which are going to be transmitted, but when we are coming for the reception part, the same frequency of signals are going to be not received with our receiver. There is a small change, there is a apparent change. Apparent means a slight change in our frequency of signals. Okay, that the change of signals is going to be calling as Doppler frequency. So the process involved to find out the Doppler frequency is going to be calling as Doppler effect. So I have already told that there is a slight equivalent change in the frequency of radar waves caused by Doppler effect. So what is the Doppler effect means? We can have an example also. When we standing on a train platform, this railway station, in our railway station, when we have a standing at the platform, if the train is passing towards us, the sound of the train is going to be having changes. So when it is going to be passing towards nearer to us, the sound of the train is going to be very high. When it is passing away from us, it is having a small frequency of signals, that is the sound waves are going to be very less. Okay, so we can have a changing of that particular voice of that particular train passing. So there is a passing towards us and there is a passing of away from us. So there is a difference between these two frequencies. So that frequency is going to be calling as Doppler frequency. Okay, it is clear, I think so. So whenever we are having this effects or to process the signals, we are going to be calling as signal processing methods. Okay, the receiver which is going to be receiving the reflected signals, that can be strengthened, and we are having number of blocks to be worked without our reflected signals, and it is having some monitoring systems to have a clear picture of that particular image. So like that we are having number of signal processing methods. So I have told that there are the principles of working, and that is the main part of the radar system is transmitter. And when we are having the transmitting of signals, when it is going to be having come into contact with our object or any target, we are going to be calling as reflected signals, and that reflected signals are going to be in different directions. Okay, so when we are having some signal processing or signal transmitting, we are going to be having effect of Doppler effect. So I have told what is the Doppler effect and what are the signal processing methods. So when we are having the receiving of reflected signals or receiving the echo signals from our target, it is having to be strengthen the signals, and it should be amplified, and it should be having some processing to detect a particular target. So in order to have a detection of target, so what is the shape of the target, what is the direction of that particular target, and what is the range of that particular target. Okay, so like that we can have a clear picture of that particular target with our radar system. So these are the main principles of working of our radar. So when we are having a look of block diagram, the block diagram consisting of mainly transmitter, receiver, target, antenna. These are the main blocks which are going to be having in our radar system. So this is the simple block diagram of radar system. So when we are having in the previous sessions, so what is the transmitter means, which will transmit some electromagnetic waves through antenna. Okay, so from antenna we are transmitting some signals, and that signals are going to be transmitted in the air in all of the directions. So when the target is going to be comes into contact, or it is going to be striking that particular target, from that target we are going to be getting some signals. So that signals are going to be calling as echo signals. So whenever we are going to be receiving that reflected signals, that signals are going to be calling as echo signals, and that signals are going to be received by our receiver through antenna. That means a single antenna can be used for the both conditions, that is transmission at the same time reception also. So when we are having the target, it is going to be receiving and it is going to be received by the receiver, so we can have the range of target. So transmitting at which time is going to be transmitted towards the target, and at which time the receiving the signals, the echo signals are going to be received. So we can have a special distance, we can find out the special distance from that particular calculations. Okay, so when we are having this receiver part, I have already told that in the receiver we are having number of signals, number of blocks to be have special clear image of that particular target. So in our receiver we are having number of blocks. That means to detect the particular target in a clear picture, we are having monitoring systems, we are having amplifiers, we are having some oscillators, we are having a displays. Okay, so for detection of the target, all of the having is going to be done in our receiver system. So that is the main principle of working with this block diagram. And when we are having a special look of radar components, while we are having this figure, I have already told that these are the main block diagrams, but not only with this, we are having number of components or number of devices involved in our block diagrams. Okay, so the main principle of working is the main important in our radar system. If we have further topics which are going to be related to our radar, we have to understand the basic principle. Okay, so this is the basic principle involved in our radar, and you have to note this figure especially, and you have to have a clear understanding of this figure. Okay, so please note this figure. I will give it 2 minutes of duration. Okay, so what are the main radar components? Okay, so I have already told that a transmitter, receiver, antenna, okay, target, these are the main components. And when we are having this outer look or inner look of our radar, the main transmitter which will generate some radio signals. So how it will be generating means with an oscillator. So in our previous subjects, we are well known about the oscillator means which will generate a particular frequency of signals. A particular frequency of signals can be generated by our oscillators. So when we are having oscillators in our previous subjects, we have well known about the crystal oscillator, Hartley oscillator, Colpitts oscillator, okay, Weinberg oscillator. These are having some frequency of signals are going to be generated, but it is not going to be used in our this radar systems. Why? Because the radar system which will be involved at high frequency of signals. Okay, so high frequency of signals is going to be used. When we are going to be using the high frequency of signals, normal when we are having a look of all oscillators which in the previous subjects, that are not going to be used. For this special applications, we are having a microwave frequency devices. So that means we are having separately, we are having microwave frequency ranges of the devices. So when we are having this devices, specially devices are going to be calling as Klystron, magnetron. Okay, so we are having special application purpose only, it is going to be introduced or it can be produced, it is going to be used. Okay, so in this transmitter we are not going to use a normal oscillator, we are going to be designing a separate oscillator which is only operated at micro frequency ranges. Okay, a Klystron or magnetron is going to be used as an oscillator in our transmitter in order to generate our radio frequencies. Okay, and it will control, it will all of the controlling of this duration by a modulator also. Okay, there is a main usage of transmitter. And in this, when we are having a transmission line in our communication systems like that, we are going to be using a waveguide. So a waveguide that will be links the transmitter at the same time antenna. Okay, it will links, that means it will having a controlation of transmitter at the same time antenna. And to have this waveguide, with the waveguide we are going to be using a duplexer. A duplexer is nothing but which is acting as a switch between an antenna at the same time transmitter. Not only with the antenna and transmitter, it is also controlling, or it is having a switch between receiver and at the same time antenna also. Okay, so that means a single antenna can be used for both transmission at the same time reception. Okay, so that can be having this, all of this can be with a single switch calling as duplexer. So the duplexer is going to be acting as a switch between the antenna and transmitter, or the receiver and the antenna. So that means a single antenna can be used for both the purpose of transmission at the same time reception. Okay, so that is the main use of duplexer. And a receiver, we are having well known about the receiver. That means in our communication systems, what it does means, the receiver which will receive the signals from the target or receive some signals from the communication devices. Okay, so in this radar the receiver will have a major role. Why? Because it which will be receiving some signals from the target or from any place or location or whatever it may be. So we are having a special image, or a special image can be done with our receiver only. That means we can have a special detection of that particular target. That means whenever we are having a target means in that target we can have a person, we can have a missile, we can have an aircraft, we can have a particular location. So like that we are going to be getting a clear image of that particular target with our receiver. Okay, that can be only done with our receiver. So in our receiver, all of the works are going to be done with our receivers, and the receiver is nothing but which is knowing the shape of the target also. Okay, and shape of the desired received signal also. That means whenever some receiving some echo signals, they are calling as pulses. Okay, so pulse means nothing but signals, received signals. So that signals are going to be matched with our filter. That signals are matched with our filter means that signals only it can be having processing. Other than that signals it will be not received. Okay, that is the main use of receiver. And to have a special outlook of our target, we are going to be using number of display types. Okay, so displays is having some processing to produce that particular signals to be easily understood by our humans. Okay, so that is the main of, that is nothing but an output devices to have a specially to know what is the target. Okay, so we are having the mainly the radar components are transmitter, waveguide, duplexer, receiver, matched filters, modulator and output device. These are the main components of radars. And mainly when we are looking about the uses, which is mainly used at weather forecasting. Weather forecasting means we can have a look of temperature, what is the temperature right now and what is the temperature at a particular duration or particular days. Okay, so what is the weather is going to be there at 24 hours or 48 hours and at a particular location. That means when we are having in our state, so other state what is the weather situations, so we can have this look with our radar. Okay, that is the main use of weather. Clear? So and the second one is military applications. So the military applications are mainly used. Why? Because some other, that is enemy missiles are going to be placed at our locations, so that can be detected by our radar. So what is the what is that missile, whether it is going to be missile or other than that, so that can be having a special look on that. So that can be possible only with our radar. And when we are having a law enforcement, so law enforcement is nothing but which is also considered under the police, under the military applications only. But what is the difference means, it is nothing but a special squad which is going to be doing only for a particular task. Okay, and for that they are having some specially groups which are going to be introducing to have a special look on the target. So for that it is mainly used of our radar. Okay, so and that is the law enforcement. And planetary observation. So when we are having the planetary observation, planetary is nothing but we are having number of planets. So Earth is nothing but a planet. So when we are having this, all of the planets, what is the location and what it is doing and how it is going to be rotating, that can be having a special look with our radar. So what is that position and what is how it is going to moving, how it is going to be revolving. Okay, so all of this planetary is going to be having some information can be done with our radar. And to have a traffic control, it is also going to be using the radar. And navigation purpose, it is also using the radar. And whenever we are having large ships which are passing from one city to another city, and for the safety of that particular ships, it is going to be using a radar. That means the radar can be placed at a particular duration or particular place, and which will be notifying the situations coming for next 2 days or next 1 day. Okay, that can be done with our radar. And to have a astronomy, so all of the Hindus are going to be very interested to know about the astronomy of us. So that can be done with our radar. Okay, so to have a knowing of speed, distance, okay, measure, so that can be done with our radar. Okay, so all of this. And not only with that, we are having a GPRS app also. That means whenever we are passing for our out of the states, we are not having any idea about that particular state, and we are not known any locations. To know about the particular location also, the radar is mostly used. Okay, these are the main uses of radar. Okay, and what are the advantages of radar? So whenever we are having an eye, the eye can detect all of the things, and eye can have a special clear cut of our images or any object or any target. So like that, it is also used as an eye, but it is acting as an powerful eye. Why? Because which will be detecting the target under critical condition. What are the critical conditions means? Whenever it is going to be having fog, when it is having some air, okay, heavy rain. So in that conditions we can detect that particular target. So we are going to be calling as powerful eye. And when we are having the advantages, main advantages of radar means, radar is nothing but the abbreviation of radar is nothing but radio detection and ranging. So for that we are calling as, we can find out the range, we can find out the location, we can find out the direction, and we can also find out the height of the target, and we can find out the velocity of the target and what is the movement of the target. That can be seen with our radar. Okay, so these are the advantages of radar. So we have a quiz on the radar. So first of all, what is the question? In a radar system, the transmitter of the radar is more sensitive than the receiver. Okay, please note this questions. Why? Because it can be most useful to our ESET point of view. So the first question you can write it. So I will have a look on this. I will give some time. Please note this questions. Okay, in a radar system, the transmitter of the radar is more sensitive than the receiver. That means more sensitive or not? Is it true or false? The answer is false. When we are having some transmitter, it is not more sensitive than the receiver. Why? Because to transmit some signals, it is having a high frequency of signals, and it is receiving some signals, it is also having some high frequency of signals. There is no comparison, or there is no more and less sensitive than the two parts, that is transmitter and receivers. And the next question is, so the radar in which both the transmission and reception is done using the same antenna are called as. So when we are having the radars, we can having the two types of radars. Okay, so that is a monostatic radar, and next one is the bistatic radar. So when the radar is having the both can be transmission and reception can be done with the same antenna, we are going to be calling as monostatic radar. Okay, so when the radar is using separate antennas for the transmission and reception, that is going to be calling as bistatic radar. Okay, so note this question. That means a radar which is having the both transmission and reception is done using the same antenna are going to be calling as monostatic radar. If the radar using the separate antennas for transmission and reception, that radar is going to be calling as bistatic radar. Okay, next, for applications like missile fire control. So when we are having some applications of the radar, I have told that it is mainly used for our missile, that is with and military applications. Okay, so at that locations, when we are using the missiles, if we are using bistatic radars or not, that is true. We are going to be using the bistatic radars for missile fire control. Okay, you can note this question also. And when a power PT is transmitted by an antenna, amount of energy incident on the target is given by an expression. That means whenever we are transmitting some signals which is having some power, that is PT, and the amount of energy incident on that particular target, when it is going to be striking off that particular target, what is the main power? So that can be given as PT, that is transmitted power, into gain of the signal by 4 pi r square. What is the r means? It is the radius of the target, square of the radius of the target. Okay, so this is the. Thank you for this session.